Well, Assalamu alaikum, dear students. I am Engineer Abdul Basit, and we are in week number 10, lecture 20 of Geotechnical Engineering 1. The topic we are going to cover here today is activity and plasticity chart. Okay, so moving on, what is activity first of all? Uh, as you all know, that the plasticity of the soil is actually dependent upon the clay particles that are being surrounded by water absorbed. Okay, as much greater amount of clay we have, and that is also surrounded with water, so the much you can say the greater the soil will be have like plastically. Okay, so simple, in the previous lecture we have already discussed this. If you can see in my video, so let's say this is that is this you can say the soil particle. If the soil particle is actually a clay particle, okay, and this is surrounded by water, so there will be multiple particles like this, many particles, and they will be surrounded by water around. Okay, so if we have a greater amount of these clay particles and the great amount of water as well to cover all the clay particles and surround it, okay, then the soil will be have more plasticity. Okay, if we do not have that clay particles, so there will be no water surrounding the clay particles or the particles, so there will be no plasticity in the soil. Okay, so you can say there are different types of soils available, different types of soils we may face in our for engineering purposes. So how to deal it, for that Skempton and many other scientists have worked on, and they have derived a relationship between the plasticity index and the clay size fraction. Okay, so the more is the clay size fraction, or the percentage finer than 20 millimeter sorry 2 millimeter by weight, okay, or you can say 2 micron particles, uh, mm, the more is the percentage of these particles, so the more will be the plasticity. So this they have a direct relationship. So Skempton worked on it, and they have like investigated different types of soils, and they developed a plot between different types of soils, and to produce a chart. Okay, uh, actually they worked on different types of minerals as well. Okay, but before doing this, they the Skempton actually derived an equation as well, and that equation is a very simple thing, that is plasticity index divided by percentage of clay size fraction by weight, is actually given a name, that is activity. Okay, so activity is actually the relationship of the plasticity index to the clay size fraction. Okay, and that relation is shown in the form of ratio. Okay, and given the name activity. Okay, this is not something very difficult or something very special, but this is just a relation or ratio of the plasticity index to the clay size fraction, as these two do have a deep relationship with each other. The more the clay particles, the more will be the plasticity index. Okay, so that's why they have worked on it, and they developed a relationship and a chart as well. Okay, so here in this table we have different types of soil clay minerals available, that is colonite, elite, morillinite, and so many. Okay, and also the liquid limit, the limit of or the range of their liquid limit is given, okay, for all types of minerals. And then the plastic limit is also given. Okay, then activity is also given for different types of clay minerals. Okay, so how this activity is actually determined, they actually determine it by this equation. Okay, and we do have a chart for it as well, and that is given here. Okay, so I have skipped a slide here. I'll come back to it when it is due to us, like there is a small change in this slide or this graph and this equation as compared to this one. Okay, so let me cover this thing first. Number one, we have that activity, okay, that is actually defined by Skempton. Okay, so he derived this simple equation for activity. Okay, and then he plotted this chart as well. Okay, so here every line or every type of dots or relationship shows different types of soil. Okay, here we have shell haven clay, London clay, and Will clay, and Horton clay, the clay taken from different areas. Okay, and they have a plot is being actually drawn here between the percentage of clay size fraction that is less than 2 micrometer and the plasticity. So for shell haven clay, the plot is like this. uh, you can see there is a linear relationship between clay size fraction and the plasticity, okay, for all types of soil, but one is having a range quite different than the other. Okay, so you can say the different types of soil, different types of clay minerals, and different sizes of the clay minerals may affect this activity of the soil, and this is quite simple to derive it from this equation. Okay, now moving backward, you can see from this equation, from this plot, you can see all the lines are like uh, crossing through this origin. Okay, if you can see, I'm going to plot it for you. Here you can see this line is moving down and it's passing through the origin. Again, this line is, if you move it down, this is passing through the origin. If you move this line down, it is passing through the origin. Again, this one is also passing. So for all types of clay, it is moving, is passing through the origin. Okay, but you can see, let me remove this first. Here it is. You can see from this chart, if we move to the actual situation, here it is. This is that ideal situation. Okay, all the graphs are passing through the origin, but this is not the case in all types of clays, and this is not the real situation. In real situation, we have this type of plot. Okay, how it is, all the clays, the you can say the plot of the all types of clays is not passing through the origin, and they are lagging behind in the on the abscissa. Okay, to up to, you can say, 10 numbers. Okay, uh, and it is not passing through the origin. So this means that the clay fraction can never be equal to 0 and can never give us a plasticity equal to 0 on a clay mineral equal to 0. So there will be some clay minerals in all types of clays that are actually available. Okay, so this plot is like not obeying this equation, this one. Okay, there is a need for a new equation where you can incorporate this lagging behind as well. Okay, so for that we have developed a new equation. This is being developed by Seed and Woodward. Okay, so they have modified this equation in this form. This is plasticity index divided by percentage of clay size fraction minus C. Okay, this C is actually a constant for a given soil. So different types of soil may have different values for C, but in this plot you can see the value for this C capital is equal to 9. Okay, so this plot is also quite clear, and you can see it from here. Now moving on to this thing, this is that equation finally developed for different types of bentonite and elite clays and montmorillonite clays. And if this is not quite visible, so you can move to your Baraja Imdaz book and you can see this in detail and in clear version. Okay, Now after this, for normally the clays have this type of graph. Okay, so this is that final graph for individual clay, or is a journal, you can say this is journal graph for all types of clays. Okay, you can say the actual situation is the graph is not meeting at the origin, but this is meeting at some distance from the origin and is lagging behind on the abscissa, not on the ordinate, on the abscissa. Okay, moving on to the plasticity chart. Okay, uh, plasticity chart activity is quite clear, I hope. Okay, if that chart is clear to you, so this one is much simpler than that one. Okay, simple. How to, this is actually the chart being plotted, you have just to use it. Okay, no need to plot this chart. Okay, just to use it. But how this chart is being plotted, so simple, we have two ordinates. One we have, this is abscissa, and on the ordinate we have that plasticity index. Okay, we have different values for liquid limit and for plasticity index. But there are two lines, A line and B lines. A line is actually plotted by using this equation, plasticity index is equal to 0.73 liquid limit minus 20. Okay, so this line is actually using the value of the liquid limit, and by putting this liquid limit, like for example we are putting 40 in it. Okay, so 40 will give us 40 minus 20, 20 multiplied by 0.3, a value, and this value will be locked in this, like searched in this ordinate plasticity index. So for example this value is like around about maybe less than 20, some value like 17. Okay, so if this is 17 or 16, so plotted here, and 40 is here, so this is 17 and 40, so you will get this point. Okay, similarly for 50, for 60, for 70, so you will get different points and you will draw this line. Okay, similarly you will get different points for u line as well, and for that equation is 0.9 liquid limit minus 8. Okay, so for example we are plotting it for 20 liquid limit, so 20 minus 8, you will get 12, 12 multiplied by 0.9, so almost 10 value. So for 20, 10, you can see this is that point. Okay, so again you will get multiple points for different liquid limit values, so you will plot this graph. So this is like already in plotted form for you, you have just to use it. How to use it? For example, you have a soil that is having liquid limit equal to 60, and you have calculated it by using that Cassagrande apparatus. Okay, and the plasticity index for the same soil is like for example 20. So 60 and 20, 20, draw a horizontal line from this 20, it will be passing through this point. Let me go back to my draw mode again, so you will see. To make it a bit clear for you people, here it is. Let's say I'm doing it in this way. Here it is. For example, you have plasticity index equal to 20, so this is that line passing horizontally, and you have that liquid limit equal to 60, so this is that line in the vertical direction. So these two lines are actually crossing at this point. Okay, now this point lies in this area, which is enclosed in this red line, this area. Okay, so you can see in this area, this area actually shows inorganic silt of high compressibility, inorganic clay. Okay, if we have another point that is like for example having you can say the liquid limit equal to 40, so it is this line in vertical direction, and it is having plastic limit equal to 22 plasticity index, so this is that point passing through it, and you will get another point that will be like Let me plot it for you. This is that point. Okay, so this point is lying in this area that is shaded to you, this area. Okay, and this area, this shaded area is actually shown here. Okay, not here, here. Okay, an organic clay of medium plasticity. So what type of soil you have, okay, you can find it out by just calculating its liquid limit and plastic limit and then plotting these values in this plasticity chart, so you will get what type of soil you have in your hand or in your laboratory. Okay, so we have different types of soil and different types of situation for that. Let's say we have cohesive soil, and then we have inorganic soil, or inorganic silt of low compressibility, low plasticity, inorganic medium plasticity, and also on. Okay, so different types of soil we have, and these soils can be like classified by using this plasticity chart only. And simple, you need to have two values for that: liquid limit and plastic limit. Okay, so I hope you do understand the A line concept and U line concept. Okay, just these equation, and this will give you the values, and you will search for these values in this end. And for A line, again you will plot the values according to this equation, and the liquid limit will remain the same. Okay, moving on here. Okay, this is again the same thing. Okay, so to discuss this thing, let me move on to my draw mode again. Okay, here it is, here it is. Okay, U line, you all know that U line is actually drawn by using this equation. Okay, this is 0.9 liquid limit minus 8, and A line is drawn by this equation. So you do have this U line and A line already drawn according to the available equations. Okay, now if you have the value of the liquid limit available and plasticity index available, so you can not only find out the types of the soil from this chart. Okay, from this chart you can also estimate the shrinkage limit. Okay, so what is the shrinkage limit here? Okay, simple shrinkage limit, I'm talking about this thing. Okay, you can find it out by using that the plasticity chart. Okay, already you have that U line drawn and A line drawn, and you have a soil that is having liquid limit and plastic limit already determined. So how to calculate this shrinkage limit for that type of soil from the values of liquid limit and plasticity index? So let's say we have a soil and it is having a liquid limit around 65. Okay, so this will be the line passing through this point, and you have plasticity index for the same soil, and that is less than 20 or 19 something. Okay, so this is that point we are getting. Okay, this is that point we are getting for our soil in the plasticity chart. Okay, so now how to find out the shrinkage limit for this soil? Okay, already you have U line, A line, and you have plotted the point as well for your type of soil. Okay, then draw down this U line in its direction with whatever it is. Like in this direction this line is drawn. Okay, just continue it downward, so here it will be. Similarly, A line should be also drawn backward in the same direction as it is available. Okay, so this will be like in this, and these two lines, this U line and O line, by drawing A line, by drawing it downward, you will get a new point, that is B point. Okay, you can see it from here, this B point. Okay, then this B point will have values of liquid limit and plasticity index in negative. Okay, as they move down in the negative direction. So this will be minus 43.5 and 46.5. Okay, so you will get a new point, that is B. Now you do have that A point of your soil. Just draw a line from this A point, Okay, sorry, from here, from this A point to this B point. Okay, now this line will intersect your abscissa or liquid limit at a point C. Okay, at this point. Okay ji. So if this is intersecting it at this point, so at this point there will be a value for your liquid limit as well. So let me show you. This C point is having a liquid limit value equal to like for example 37 or 35 something roundabout. Okay, so this 37 is now your shrinkage limit. Let me repeat it again. You do have U line, A line in the plasticity chart. Just plot it down backward, okay, in the same direction as it is. Then plot the A line in the downward backward at in the same direction as it is. These two lines will intersect at point B, and then plot your soil type in this chart. Let's say it is having a liquid limit about 65 or plasticity index somewhat here in 19 or so. Okay, then you will get this point by plotting their soil. Then you have A point and B point. Join these 2 points A and B. This line will intersect the liquid limit axis, or you can say your abscissa at point C. Okay, and this point C will give you the shrinkage limit or estimated value of the shrinkage limit. So from this whole discussion, it means you can determine the type of soil from plasticity chart, and also from the shrinkage limit from the plasticity chart. This is the method for shrinkage limit, and this is for determination of the type of soil. Okay, so that's it. Inshallah, in the next lecture we will discuss about the soil structure and classification of soil. I hope you have got something new to learn from this lecture. Thank you very much. Thanks for your time. Assalamu alaikum. Good luck.